As always, our show is sponsored by Memoria Press. You can find our curriculum at memoriapress.com.
Welcome to Classical Etc., a show that dives into the philosophy, culture, and heart of classical education. You're in the studio with Shane Saxon.
All right, welcome to another episode of the Classical Etc. podcast. I'm sitting with Paul Schaeffer, Dr. Dan Sheffler, and a special new guest, Tom Sculthorpe, who is the math guy at Memoria Press. And there's actually a very specific reason I've invited you three down here today. I don't know if you noticed this when you were walking in the room today, above the door, and people who don't know Memoria Press don't know that we actually have an Attic Greek inscription above the door that says, "Let no one ignorant of geometry enter here." But you three can enter.
I suppose we can enter.
One of you guys
and for those who don't know where that slogan comes from, it was inscribed above the gate of Plato's Academy.
Oh, that's what it was. I thought it was our studio. That's my bad.
Because Plato thought that you had to have a grounding in the rigorous learning and the rigorous style of thinking that geometry taught you before you were really ready for what he was going to teach you in his school.
I knew that you would know, Dr. Dan Sheffler, and I appreciate that. So
I would like to make it known that on the last podcast you referenced me as being inaccessible and I forget the exact word you used, unrelatable maybe, and yet this podcast you invited me because I will be relatable.
Well, that's right. You're relatable because what we're talking about today is math. Tom is the math guy. We've brought him in to be the math guy from Memoria Press to be working on math things, and so that's what the conversation is today. It's math. And a lot of times when you talk about classical education, we've talked about this on the pod before, people tend to gravitate to classical ed who are word people, who love books. But as Tom will expound for us, I'm sure, that is it's a bad distinction, that it's all a part of classical ed. So that's where we're headed. But Tom, it's a tradition on this show, because we're just conversing like friends, to ask, what are you reading right now? What are you reading?
Well, my most of my reading time is dedicated to the scriptures every morning because I'm a PhD student and I'm studying for that. And other than that, I'm reading the Wing Feather Saga with my children at night before bed. Maybe not so classical, but the kids are really enjoying it, and yes. I am too. It's pretty exciting, and we're having a good time.
I like how your PhD is just reading the scriptures. That's your research. Just read the scriptures. A purist.
Yes, I'm also reading a book by Jeffrey Pulse called Figuring Resurrection. He argues that Joseph is a death and resurrection figure in the Old Testament. So
I like it. Dr. Sheffler, what have you been reading recently?
I just went on vacation last week, and we have a little tradition, my wife and I, when we go on vacation, of hitting like every used bookstore in the city that we go to. So we went to every single used book place in St. Louis, and I picked up a book right off the shelf, Eliada's Myth of the Eternal Return. And it's about this kind of theme throughout a lot of different cultures of a cyclical view of history and the importance of that. Why it's his view is that people do this because we have a kind of buildup of guilt, and so we need some kind of way of putting the burden of these irreversible actions behind us definitively. Very fascinating book. I read it all just in like one go in one afternoon because I was on vacation. Burned through it.
Vacation reading, the best.
Oh yeah.
Paul, what have you been reading recently?
I'm still on Don Quixote. Okay. I finished Return of the King the other day, which was wonderful. It's been at least, it's been probably 15 years since I read it, and I did not remember the Grey Havens chapter being as moving as it was. So that was I very much enjoyed the end of that book.
Do you also enjoy the Shire episode at the end? For those people of us like of my generation raised on the movies, when you get to the end of Return of the King, when you're actually reading it and you get to the whole Shire episode, it's just like, oh, this is awesome.
Well, you feel like
a whole nother book.
Yeah, it is. It is like a whole nother book, but you feel like, okay, sorry, spoiler, the ring is destroyed. They've
had 100 years.
The king has returned,
and the Titanic sank.
And
different book.
You feel like between those two things, the ring being destroyed and the and the king has returned, that we should wrap up really quick, right? Like it's over. But no, I mean, coming back to the scouring of the Shire, it's a wonderful moment, because it's, Gandalf tells them, they're like, aren't you coming with? He says, no, you've learned. You can do this without me now. And so, and to see them kind of rise to that occasion is a beautiful thing that I think most people don't expect, because you expect it to be over. And I'm sitting here going, I got another 100 pages here to go. But they were some of the best pages in the entire trilogy, I think.
Yeah, absolutely. It kind of turns the focus back to the Hobbits, kind of where the focus should be as you're reading the trilogy.
Yeah.
I just finished reading Wuthering Heights, and it's a pretty incredible book. But I've turned to a quick reread of The Picture of Dorian Gray. I don't know if any of you have read that book, but just a fascinating, interesting novel.
Very interesting novel.
But hold on. I think for our listeners, you mentioned Wuthering Heights. You mentioned you couldn't have a real opinion on it until you got to the end.
Sure.
And I know Tanya and Martin aren't here, but I do feel like for our listeners, to do justice, you need to opine.
Yeah, so I still think Jane Eyre is the better novel, personally.
I agree.
But I do find Wuthering Heights to be very interesting. And I think what it does that many novels don't do well is that it draws you. Both of the novels are very similar, and I think do the same exact thing. They draw you to the very breaking point of asking, can love conquer evil? Mm-hmm. And over again, for hundreds of pages, the novel says, no, it can't. Mm-hmm. Cynicism and despair will conquer love. And then at the end, Harridan and young Kathy, spoiler alert, actually do come to love each other, and they put aside generational cynicism and destruction, and they love each other. And through it, they embrace learning and beauty, and they escape, the darkness of Wuthering Heights, and they bring beauty to it, planting a garden in the outside of the house. And so I found it to be a beautiful novel in the same way as Jane Eyre. I did think Jane Eyre was just slightly better, but I like both a lot.
That's a good reading of both of those novels. I like that.
Thanks, Dr. Dan. So let's turn our attention to math. So, Tom, a lot of people in the classical education orbit, like I've said, will come to math or come to classical ed as word people. We had a whole episode on like translating other languages and learning secondary languages. You're a language person too. I know that. You and I were in a Septuagint Greek class together. That's how we met. And Hebrew. I know you're that kind of person too. But there's a special role for math in classical education. They can't be separated from each other. Explain why that is.
Sure. Well, to return to Plato, my understanding is that Plato was a Pythagorean, and the Pythagoreans argued that the whole world is mathematical. And so it might be helpful to think about math as another language with which we use to describe the world that we live in. I think that is the tradition that we are all striving to build upon in classical education.
When Shane asked the "What are you reading?" question, I could have answered just as well. Another thing I read on vacation was Iamblichus's Life of Pythagoras, in which
a classic Dr. Sheffler move.
It's great, but you're exactly right. There's a deep kinship between Platonism, the whole Platonic philosophical tradition, and that the earlier Pythagoreans. And so this idea that there's somehow a war between quantitative analytical reasoning and more humanistic, qualitative, imaginative reasoning. There are differences, of course, but it doesn't have to be antagonistic. Right? God gave us both of those sides of our minds, and you really need the one to help the other, and vice versa. You're going to have a really hard time thinking through rigorously some of those more humanistic, language, literature-oriented things if you're having trouble with that analytical side of your reasoning, and vice versa. If all you can do is, just the quantitative analytical stuff, and you can't relate that to the human condition, you're also going to get a little dried up in your mind.
Just because I like pinning all the woes of our era on the Enlightenment.
Sure.
Maybe one of you two could pitch in, right? Because we say there doesn't have to be this antagonism between the two, and I don't think there was the antagonism in the ancient world, right?
And throughout the medieval world,
right? So where is it coming in the Enlightenment? Is that like the major impulse?
Well, I mean, I'm a history of ideas guy, you know me, and so I want to be really rigorous about exactly where we pin that, but and I haven't done that research, but that is my sense is with Descartes, with Leibniz, you start to get that transition between kind of a rigorous separation between these two modes of knowing, that which gives geometric certainty and this other stuff that we're going to kind of put in the dustbin of history.
Yeah, it seems to me that that Newton and Leibniz and the scientific revolution as a whole saw themselves in the following in the footsteps of the Pythagoreans and Plato vice Aristotle, where Aristotelianism had kind of ruled the day with respect to natural philosophy or science, including math for millennia,
years.
Yeah, a long time. So I think they were getting back to the world is mathematical, and out of that came Descartes' algebraic notation and Newton's calculus.
And what happens there, kind of in layman terms, it seems like, is that you start to divide kind of metaphysical reality from those things which we can observe. And you start to say only those things that we can demonstrate are true. And they have to be demonstratable to be true, and nothing undemonstratable is true, right? And so that maybe is what divides math from something like poetry, right? Because I can't necessarily prove to you that a poem is true, but it is. I can't demonstrate that.
At least not in the geometric
not
sense
in a
of proof
geometric,
or
analytical way, right? And so it seems like there is a connection there.
Yeah, we could probably root that in the Enlightenment and the idea that we ought to pursue some kind of objective truth through the sciences and through mathematical science in particular.
And so how do you think, though, in classical education, we are trying to not necessarily say, okay, because of ways that the analytical sciences were used to critique, a biblical metaphysic or a Christian worldview, what we're actually trying to do is say, no, math is created by God. So how does that happen in classical education?
Well, I think, early on, you teach your kids basic math facts. We start with drilling arithmetic. And so we build, first of all, that foundation of just knowing that these things are true. And I think that gives the kids a really important, I don't want to call it a moral virtue, but it's like an intellectual virtue of knowing that certain things are true, that this is objectively 2 + 3 = 5,
Yep.
And then as we move on and they start to add more onto that foundation, into the arithmetic or into multiplication, into algebra, into geometry, trigonometry, calculus, they start to have this expanding understanding of this deeply complex, but also highly rigorous and highly dependable system of thought, and they're training their minds to think through that. And I think that integrates perfectly with a Christian worldview, with a focus in your other subjects on poetry and literature and philosophy and history and all the rest.
Paul,
Go ahead.
Paul, have you seen that bear out in your experience as a teacher and a leader of a school, the relationship between students who excel in math and other subjects?
Well, I mean, part of this is we're living in this world in which people like to categorize themselves as word people or math people, right? And so you will see, purely because of the effort of the student, that they do poorly in language-based studies, but they excel in math, or vice versa, just because they're like, that's not my thing. But you do have also another large contingent of students that just kind of excel in both, right? And so kind of what I have tried to do as much as possible, and it's a project of years and decades, is is to try to help, because even our math teachers, and Tom, you were one of them, and I'm glad you're in the position you are now. But a lot of math teachers that come to classical schools now are still thinking in this post-Enlightenment, post-scientific revolution mentality of this is how we know something's true, is if we can prove it mathematically or prove it scientifically. Whereas, and so even in a school, you tend to get this division purely because we aren't all trained with this ancient mindset, ancient medieval. I'm going to include medieval, Dan. And so it's. We are getting, I think, as the classical movement is maturing and growing, we're getting more of that integration. We're getting more of the teacher that can walk into a math class and say, this is a liberal art, right? And this is why it's a liberal art. But it's still a project of generations to really fully embody that, I think.
When I was a student, I didn't go to a classical school. I went to like a pretty good public high school, and I really gravitated to math. And I went really far in math for my high school, precisely because that was the one subject that I could find in my school where the teacher was willing to tell me, this is what the truth is, and this is how you can know it, and I'm going to give you a definite method for knowing the truth. Whereas in virtually every other subject, including even to some extent sciences, there was this perpetual, we don't really know. It's kind of whatever you want to think, And I was really turned off by that as a student, because I was like, well, look, if you're the English teacher and you can't tell me what constitutes a good sentence or a good essay or a good book and how to get there, what's the point of this class? What am I even doing? How do I even know how to write my essay? So I think some of that categorization that you're talking about of people is, I'm a math guy or I'm a math and science guy, is they're really just truth people, right? Yeah. They're into truth, and that's where they can find it. And so I think we can do better.
But in a classical school, right? Everybody should be saying, every teacher should be saying, or in a homeschool, this is what is true, right? And that's one thing. I remember Cheryl Lowe used to always say, like, a progressive school is one in which they ask you what the answer is, but they try to hide the answer from you, and whereas in a classical school, we're saying, no, here's what the truth is, and here's the different modes of coming to know it. Right. And that's why I'm going to make a plug for my philosophy course. Because as far as I'm aware, it's the only place in our curriculum or in most classical schools where we actually talk about what the Pythagoreans thought and believed and what their influence was on the later philosophers. And so you do start to get this melding of the quantitative with the philosophical.
Paul, are you still an advocate of worshiping the number 10? Is that in the course?
Insofar as 10 is a participation in God.
Oh, there we go. Well, you bring up an important point. I think one of the interesting things for people who appreciate classical education and philosophy is that math evokes so many interesting metaphysical questions. Like, the classic one is Xenos Paradox, which you've probably heard, and that is, in order to cross the street, you have to cross halfway from point A to point B. However, in order to cross from halfway from point A to point B, you have to cross halfway to point A to point B. But in order to cross halfway to point A to B, you have to cross halfway to point A. And so because there's an infinite regress of halfways, it's not actually possible to cross the street. And yet
even Achilles could complete an infinite number of journeys in a finite time.
There you go. Yeah. And so, you have these paradoxes that's a mathematical paradox, and there's many ways to answer it, but part of the difficulty there is just the slipperiness with which we are trying to describe geometrical realities with words. And that's what really math is, right? It's just trying to describe reality with words in a computational system.
Well, this is why Newton's calculus was so important, because the question is Zeno's paradox a mathematical problem or a physical problem? You and I can go outside and cross the street right now and say Zeno's paradox doesn't make any sense. And yet he makes a good point. And his point, we can see it concretely in numbers, for instance, as well, is are any two numbers ever adjacent to each other?
Right.
No, there's always another number in between. It's the same idea. Mm-hmm. There we see numbers representing these real world problems, right? But what Newton's calculus did was it solved Xenos Paradox mathematically and brought math into more alignment with the real world as we see it and experience it.
Mm-hmm.
Right.
Because let's define Newton's calculus here, which is
he found a way to measure infinitesimally small distances or times.
With the sum of an infinite series.
Yes.
And so that solves problems like being able to cross the street, or the other famous one is the arrow. If an arrow is being shot, then at any particular point in time, it's not moving. So how do you judge its velocity? So different things like this are what calculus solve. But these are not just math problems; they're metaphysical problems. They're language problems, and that's why Aristotle's answer, for these problems was mathematically dissatisfying. And so it's interesting to try to see how philosophy and math do connect.
I say mathematically unsatisfying, but philosophically very satisfying.
For some
people, very satisfying. But I like the example. I was telling y'all this story the other day where when I was teaching, we were going through like book 1 of the physics with the students, and where maybe it's book 2, I don't remember, but it's where Aristotle's going through all his predecessors saying, well, this guy was wrong because of this and this guy was wrong because of that. And I think it's Anaxagoras where he has this infinity of infinities, and Aristotle's like, well, that's ridiculous. Just think about it, And all my students were like, but Dr. Sewer says that, the math
calculus
class,
teacher
that there's infinity of infinities. And so Dr. Sewer and I had a very brief conversation, because he was like, yeah, we're not saying that there's actually an infinity of infinities, but that mathematically it's conceptually possible.
Mm-hmm.
Okay.
When this is where you have to make the distinction between, are we analyzing intelligible reality, the noeta, to use Aristotle's term, or are we analyzing material reality? So if we're talking about, could it be that something move infinitely fast? No. Could it be that that there's an infinite regress of real efficient causes in the physical universe? No. Okay. But if we're discussing in intelligibles, right? The pure structures that we understand with our minds, well, then that's a slightly different question.
Right. You can measure the distance around a tree, even though it's a circle. You can measure motion, even though it's something that's moving through time. Yeah. So it's all interesting questions, but bringing it back to earth a little bit, Tom, what does it mean to be a math teacher who integrates and doesn't separate out for the students and say, my bright ones, you're STEM students, and the rest of you don't matter. Go to poetry class. How can you be a math teacher who understands the importance of forming the whole person?
Good question. So number one, I'd want to make a distinction between the primary grammar stages and then the later stage education, high school and above. Early on, like Dr. Dan said, we want to focus on math facts, teach objective truth. These things are just true. My kids can see it when we teach them this at home by counting M&Ms. And they can see, numbers are real, and I get to enjoy them. But as the students grow, we can start to integrate what they've learned about how math and the real world line up with everything else that they've learned with regard to philosophy and history. And so one of the best questions to ask when we're looking at mathematics is, what problem were these people trying to solve? Mm-hmm. What question does this process answer? And that, I think, is the key to orienting mathematical study in Western tradition and classical education.
And helping the students see that this isn't useless.
Yes, exactly right. I mean, that's how it started. That's how math started, was how can we describe motion, which is exactly what Zeno and all these people were trying to do. And then as far as the separating students, the problem there is basically the STEM impulse, that we're going to take science and mathematics and then tech and engineering, which are a derivative of them, and separate those from the liberal arts. The problem with that is, in our classical tradition, these things were all integrated together. And in fact, like we said, Plato saw math as the entry point to everything else, because the whole world is mathematical. So I think we need to reject the STEM impulse, and as far as we can, keep everything integrated. And now that's not to say, now I was a physics undergrad, so that's not to say that when we get into specialization, STEM doesn't have a place.
Sure.
It surely does. But I think what would make the most effective STEM of people who operate in STEM vocations would be those who have an integrated background.
Sure. It seems like what people are doing by focusing so much overly on STEM when they're preparing students for STEM fields is that they're cutting off their noses to spite their faces in some ways. That it takes creativity to excel in a STEM field. It takes problem solving skills as much as these tactile skills that they're learning.
And it takes virtue as well.
And virtue. That's a good point. So what were the problems that they were answering? It might be a helpful exercise just to kind of illustrate what you were saying. What were the problems answered when something like algebra was first developed?
Yeah. So the fundamental theorem of algebra has to do with solving polynomial equations. So in other words,
I was an English major. Help me out.
So I'm going to solve for x in an equation where the x variable, the variable is raised to a certain degree. It could be a first degree, a linear equation, a line, second degree, quadratic, parabola, a curve basically, and then on and on. So how can we find the solutions to a polynomial equation? And that's what the fundamental theorem of algebra addresses. And as far back as ancient Babylon, we have civilizations trying to solve for unknowns. And algebra took thousands of years to come to fruition. It really, again, it came to maturity under Descartes and the Cartesian plane, the XY plane, and coupled with his algebraic notation. For much of math history, people talked about math problems in words, paragraphs. All my students hate word problems.
I picked up a book that has a facsimile of a 16th century copy of Nicholas of Cusa's Ludus Globally at one of these bookstores over vacation. And so it's written in Latin, and it's all about spherical math and spherical mechanics. And exactly as you're describing, it's just straight paragraphs of words. And I read some of it, which was first of all challenging just to get through the kind of paleography of the old way of printing Latin. But you're right, it's monstrously difficult to follow. Wait, what? This number is going there? And so thank God for Cartesian notation.
Right.
Well, and I wanted to raise the issue. I don't want to get us off of algebra, but when we talk about let those who know geometry enter, right, is what Plato expected from a geometrical student the same as what we expect of a student of geometry?
Yes.
I think that's it's a question that maybe we don't want to get to here, but I think it's a question.
No, I'd like to get into it, because what do you mean by that?
But it gets back to this idea that math was taught in words, right? So to go study straight Euclid is a very different experience, which was my experience.
Maybe
in high school.
someone unpack straight Euclid.
Well, there's no numbers in Euclid's elements.
Okay. And Euclid being a person who
and
wrote on geometry.
Diagrams. Yes. Right. You can get modern editions that print helpful diagrams alongside of the various theorems, but you have to remember that for hundreds of years, Euclid's Elements was just statements followed by proofs in words.
So do we think that when students were studying Euclid, that they were attempting to know those theorems like rote, or was it conceptual mastery? Do we have a sense of that back at that time?
Well, so this is interesting from reading the life of Pythagoras. So the students of Pythagoras were divided into the akousmatikoi and the mathematikoi. The akousmatikoi simply heard the doctrines. Akouo means to hear in Greek, right? So they heard the doctrines and learned to repeat them. Whereas the mathematikoi, where we get our word math from, matheo means to learn. So they were the inner circle of Pythagoras' students who actually learned the doctrine. And the way Iamblichus phrases it is they learned the doctrine with a demonstration. They learned the logos, the ability to actually prove why that doctrine was true, why the Pythagorean theorem works, not just learn to repeat a squared plus b squared equals c squared.
Sure. And so, Tom, when it comes to our students who are in high school, do you think that every student should take calculus, or what do you think students who are entering high school in a classical tradition, what's the goal?
Great question. Yes, I think that our classical students should take geometry and learn how to explain mathematical concepts with words. I think that all students should learn calculus. Yes, the fundamental theorem of calculus, limits, derivatives, integrals. Now, the question in my mind is, to what extent do all students need to learn this? Because again, I think that there's a degree to which all classical students need to learn math. And then there's a degree beyond that where if I want to specialize in mathematical-based science or something like that, I'm going to need to go farther. So for instance, in my undergraduate education in physics, I went up through differential equations and then took a special applications class for physics. Not everyone needs to do that in order to be a well-rounded individual, right? So one of the things, I just finished reading a calculus book by Mitch Stokes called Calculus for Everyone, which was mostly in paragraph form, which I thought was innovative and strange. But it is definitely not your normal calculus book. What he's trying to do is orient calculus in Western tradition for classical students so that they can understand why calculus arose and what problem is solved. Now, there's math problems in the book as well, but it's not your typical, maybe more STEM-oriented calculus book that is just, here's what a derivative is, now solve all these problems, right? And not explaining what problem the derivative solves in the real world and mathematically. So I would say that, yes, we want all of our students to learn calculus. I think, a course, something more like what Mitch Stokes has put together and what he teaches at New St. Andrews, maybe the recipe for students who aren't interested in STEM fields as a vocation. And so that's what I would say about that.
Yeah. So, Paul, speaking to people, students, we've said over and over that this division between, word people, math people, we don't like it very much. What do you say to students on a psychological level, maybe, or an encouragement level for a parent who has a student or a student themselves who they think of themselves as a word person, or maybe they have genuine struggles with processing numbers or, computational difficulties. What's your encouragement to them, and how would you encourage them to approach growing this well-roundedness?
Well, first of all, I would say that up until Tom has been saying what Tom was saying, I had no path forward of a calculus for everybody, right? So I would I have lived more in the world, and if you've completed Algebra 2, you've completed geometry, pre-calculus is a very good thing, but not necessary for everybody. And so it becomes a conversation with the parent of like, okay, what is this child geared towards doing? Because when you get into upper high school, you are starting to think about specialization, right? Mm-hmm. And so, there are certain essentials, that you have to, the student's going to have to accomplish because they need to be well-rounded. They need to be able to think quantitatively, think linguistically, and integrate the two. And so, if you're trudging through Algebra 2 and you're just not getting it, well, that's where a teacher like Tom, who used to be with the Online Academy, could come alongside and help that student, right? Or rephrase what's going on, or explain why in the world we're even doing this, right? I love it when the teachers take time to say, okay, I'm not digging immediately into polynomials. Like, what What's our reason for doing this, right? Because that motivation is key, right? And so, I mean, you have all sorts of different conversations of, is it the motivations? Is it the foundations? Can they just not even multiply 7 times 8, right? But it's all within a context of, this is going to be the best thing for this person's human flourishing, right? And so whether we're going to learn the discipline of hard work and determination, or whether we're going to be, finally turning on that flame that they're like, I love this now. That's what we would love to get everybody to. We don't get everybody there, right? But but foundationally, you have to do it because it's going to help you be a better human being.
Paul, the most popular questions that I got in class of teaching algebra for MPOA was, why do I have to know this? Or how am I going to use this in my life? And unfortunately, or not, oftentimes the answer is, you're not going to use this in your everyday life. You're not going to every day wake up and solve polynomials. But what
says you?
This is Dan's daily morning activity.
That's from the math guy, right? But this is where what I kind of want to push back on is the notion of education as preparation for a vocation. There is a point where we need to prepare for a vocation, but for the most part, and I would say through high school, we want to think about education as educating. And so that's why I'm arguing for calculus for everyone, because I would argue that calculus is a necessary component of a well-rounded classical education that prepares you for any vocation.
But I think you're clarifying that calculus for everyone does not mean calculus A, B, or calculus B, C for everybody.
No, exactly right.
And that's where I haven't had a path forward to get to calculus for everybody.
Yeah.
In order to as you said, derivatives and what are the
integrals and limits?
Yeah.
Yes.
I'd studied calculus way back. I've just let that fade out. I think I would agree with that, but today's students and parents have a hard time accepting that if they are perceiving calculus as being that which I need in order to become an engineer or to become a physicist. Right. And that, I think that's where, I would expect that if a student's coming in starting algebra 2 in 9th grade, when you're talking like getting to that calculus for everybody, we're talking they could do algebra 2 geometry in this calculus for everybody in 3 years.
Yes.
Right. And that is very doable for a student.
Yes.
But I have students coming in pre-algebra in freshman year.
Right.
So, and I think it's also important to clarify that calculus for everyone doesn't mean calculus for the practical application to everyone's career.
Right.
Right. There is as we've said many times, there is a place for specialization and learning some of those skills that you're going to need for your specialized vocation and career. But there's also a place for just, it's intrinsically beautiful and worth knowing. And as with all our subjects in classics, we don't learn Latin primarily to learn some skill that you're going to use as an accountant. We don't learn literature so that you can have some skill that you're going to use when you grow up and become a HVAC technician. Right? That's not our primary goal. We're learning these things because they're intrinsically worth learning and worth thinking about. I remember when I had the light bulb moment come on for me, I had done, Cartesian, plane, working on parabolas, all those basic algebra. And then I realized these are conic sections, right? Somebody finally taught me, kind of pre-Descartes, the reason that they were thinking about parabolas was because they were taking slices of cones. That's what a parabola is. And I was like, what? This is 3D geometry that I've been doing this whole time, and that's just cool. Like, that's just elegant that is true, that there's this kind of unity to all of these things. Another light bulb moment that I had was when I finally realized that in music, the circle of fifths in music theory and the harmonies in music theory had everything to do with ratios and logarithmic scales and all of these kinds of things. And to see, this is all a unified truth, that truth is one. And that's just cool and beautiful and worth studying for its own sake. I think
you bring up the most important piece of it, and that is it's beautiful and worth knowing. But I think even a secondary thing that I've thought about, I quipped that I was an English major, but I also took calculus. And I think one of the things that was good for me, in that I've never through life, I haven't used calculus, but I've never really run into a system of complex numbers or computation that I haven't thought, if I spend enough time on this, I figured out calculus once, I could probably figure this out too. And, it equips the student with a kind of internal equipment that allows them to face the challenges they're going to have in life.
Yeah. And I think I like to poo-poo calculus a little bit, because my experience was when algebra came easy to me, I never really questioned why I was doing it. It was just, I could fill it out and it was great. It was easy. And then when I hit geometry, I studied straight Euclid with diagrams. And so no quantification of how many degrees this angle is or anything like that. But then in that process, we were being shown geometric proofs for algebraic equations we had used prior. And that's when I was like, oh my gosh, this all makes sense. And then I hit calculus, and it was pure, just here's how you compute this thing. And so I never got that beautiful moment in calculus. Yeah. And so, this whole podcast has been enlightening to me in several different ways, which has been wonderful. But it is, I agree. I feel like I could figure out anything mathematically because of that experience, but I really don't know what I was doing.
Sure. So, Dr. Sheffler, when Mrs. Lowe named this school that we're at here, she called it Highlands Latin School. But when you go, I've gone back and listened to a lot of her speeches and read a lot of her things. When listening to her, she would say at the heart of classical education is Latin and math. She talked about these two being concurrent, because public education hadn't totally lost math, but she felt like there needed to be something like math on the art side. And I've always thought that parallel was really interesting. But when people think of Memoria Press and think of Highlands Latin School, they think about Latin because that was the fight we were fighting.
But I thought you missed an opportunity to say, why isn't it Highlands Geometry School?
Well, it should be Highlands Latin and Geometry.
I think it's important. So historically, you have the 7 liberal arts, right? And in the classical education revival movement, we really like to focus on the trivium part of the 7, the 3 out of the 7. But what are the other 4? In fact, I think if you go to a lot of classical ed conferences and ask random people, so what are the other 4 liberal arts? They probably couldn't tell you. Okay, but the quadrivium is just as important. And guess what the quadrivium is? It's all math. Yeah. Okay, music and astronomy are in there, right? But those were understood to be mathematical sciences throughout the Middle Ages, right? So you really can't lose that other side of what a classical education is. It's the whole picture there of the 7 liberal arts.
Yeah. That is exactly what I'd like to accomplish here, is the reintegration of the trivium and the quadrivium, the reintegration of math with the classical liberal arts, because it has been a STEM field for too long.
You heard it here first. All right, well, thank you guys for this conversation, and we'll see you next time.
Thank you.
Thank you.
Thank you for listening to today's episode of Classical Etc. If you'd like to show your support for the show, then you can leave a like below. If you'd like to add your voice to the conversation, then you can comment. And if you want to follow along with us on this journey, then please subscribe. Thanks, and I'll see you later.